Hello everyone, in this video we are going to learn about some applications of trigonometric functions. So to begin, let's begin by understanding this transformation equation. Here I would like us to understand what do these parameters a, b, c, and d control, and what are they also called. So to recall, a could be positive or negative. The way you want to think about it is like a light switch. If it's positive, there's no reflection, but if it's negative, then there's going to be a reflection in the x-axis. And when you consider the a value without the sign, that is the absolute value of a, that's what we call the amplitude. It's the distance from the midline. It's the distance from the midline to a peak or a trough. The b value over here is related to the period. It's not the period, but it's related to the period. Again, it might be positive or negative. You want to think of it like a light switch. If it's negative, then there's going to be a reflection across the y-axis. And if you consider the b value without the sign, then it relates to the period. It actually affects how long it takes to complete one cycle. And the relationship is that you want to do 2 pi divided by the absolute value of b. This is equal to the period. This is your horizontal stretch or compression. The c value is called the phase shift. It's going to move the graph left or right. And lastly, the d value is your vertical shift. This is also the equation of the midline. So understanding these parameters a, b, c, and d is very important when we start looking at word problems, because we need to be able to understand and extract this information to model the problem. So let's begin by taking a look at some problems. Here's the first example. In this problem, we are given an equation that models the average monthly temperature of Toronto, Ontario. In this equation, T denotes the number of months, with January represented by T equals 1. Okay, so when you plug in T equals 1, that is the average monthly temperature for January. When you plug in T equals 2, the equation will output the monthly temperature in February, and so on. And so the question is asking, during which 2 months is the average temperature exactly 12.5 degrees Celsius? So to solve this problem, we are looking for values of T that satisfy the following equation. We want to know for what values of T is the temperature exactly equal to 12.5 degrees Celsius. And so this means we have to set the equation equal to 12.5 and solve for T. And so to do that, we can begin by subtracting 12.5 on both sides to get this equation, and then we can divide both sides by 15.8 to get this equation. And so now we're asking, when does sine of this input equal 0? Now, since this looks a little bit complicated to look at, how about we introduce a new variable? Let's call beta the inside of this value. Okay, so beta is going to represent pi over 6t minus 2 pi over 3. And so what we're really trying to solve is, when does sine of beta equal 0? And so hopefully you remember what the graph of sine looks like. The graph of sine looks something like this, pictured in orange. And when does sine of beta equal 0, right? Sine of x equals 0. Well, that happens at every integer multiple of pi, right? At 0, pi, 1 pi, 2 pi, 3 pi, 4 pi, and likewise on this side, minus pi, minus 2 pi, minus 3 pi. So sine equals 0 precisely at every single integer multiple of pi. And so that's what I've written over here. Beta is equal to integer multiples of pi. K is an integer. Okay, but now we undo the substitution. Remember, we're not after beta, we were actually after t. And so let's undo the substitution and replace beta with what it was, with what t was, which was this expression. And now using this expression, we can solve for t, no problem. So let's add 2 pi over 3 on both sides to get this equation. And then let's just divide by pi over 6 on both sides, and we get this expression. And so this is the general solution to this problem. However, the problem asked for the first 2 months that correspond to an average temperature of 12.5. And so the first 2 months are going to be corresponding to k equals 0. When you plug that in, you get the 4th month. And k equals 1, when you plug that into this general expression, you get the 10th month. And so therefore, since the first month is January, the 4th month is going to be April, and the 10th month is going to be October. These are the 2 months in which the monthly temperature is exactly 12.5 degrees Celsius. Okay, great. Now let's take a look at the next problem. The next problem is about a Ferris wheel. A Ferris wheel has a diameter of 15 meters and is 6 meters above ground level at its lowest point. It takes a rider 30 seconds from their minimum height above ground to reach the maximum height of the Ferris wheel. Okay, assume that the rider starts the ride at the minimum point. And so the first part of this problem is to model the height of the rider versus time. We want to use some kind of model, which would be a trigonometric model, because a Ferris wheel is cyclic, right? It's going to repeat in regular intervals. And so we want to use either a cosine or a sine function to model the situation, the height of the rider versus time. And so the first thing we need to do is extract all the useful information. In order to build the sine equation or the cosine equation, we need the amplitude, we need the phase shift, we need the equation of axis or the midline, we need the period, right? We have to extract all this information from the problem. And so let's take a look at this physical diagram that I have of the Ferris wheel. We know that the Ferris wheel has a diameter of 15 meters, okay? We also know that it's located 6 meters above ground. And so let's say we have a vertical axis that corresponds to the height. Here's height equals 0. Then we know that the Ferris wheel is placed 6 meters above ground. So this is where the Ferris wheel starts. And then we know also that the diameter of the Ferris wheel is 15 meters. So if I do 6 plus 15, I can get the maximum point of the Ferris wheel, which is going to be 21 meters. Okay, so we have the maximum point being 21. The minimum point is 6 meters. And so now we can find the A value, which is the amplitude, and we can also find the D value, which is the equation of axis or the midline. And the formulas for this is just max minus min divided by 2 and max plus min divided by 2, right? The equation of axis is just the average of the max and min, right? It's the value that lies in the middle of the max and min, so it's just a simple average. And if you don't want to memorize this formula, you can also think about it as here's 13.5, right? And what you can do is just 21 minus 13.5, and you'll get 7.5 as the amplitude, right? The distance from the midline to the maximum. Or you can also calculate the distance from the midline to the minimum point, in which case you would do 13.5 minus 6, right? So yes, you can memorize the formulas or understand it physically what's going on as well, no problem. Okay, now let's talk about the period. So the problem told us that it takes the rider 30 seconds from the minimum height above ground to reach the maximum. Okay, so it takes 30 seconds to go from minimum to maximum, but the period is the length between two consecutive peaks or two consecutive troughs. And so for that reason, the period is actually going to be 60 seconds, right? If it takes 30 seconds to get from the bottom to the top, we can assume it's also going to take 30 seconds to get from the top to the bottom. And so the distance, the horizontal length from the minimum to the minimum is 60 seconds. Great, so now that we have the period, we can actually find the B value, which we require in our equations, right? And what's the relationship? Well, you just have to do 2 pi divided by the period, and that's equal to B. So we get pi over 30. That's the B value. Great. Now that we have extracted all of this information, let's make a nice graph of this, and then that will help us create the equation that we're looking for to model this problem. Great. So let's take a look at this graph. As you can see, on the horizontal axis, we have time, and I split it up into 30, 60, and 90, right? We know that at time t equals 0, we start at the bottom. Then at times t equals 30, we reach the top. And then at time t equals 60 seconds, we reach the bottom again, right? This is one full cycle. And then after that, we continue like in this fashion forever. One way to model this equation would be to recognize this as a regular cosine, right? But this is a reflected cosine. It's a cosine that's been reflected over the x-axis. And so for that reason, we put a negative value. We put the A value, the amplitude was 7.5, cosine. We put the B value that we found, which was pi over 30. And then cosine starts at 0. And this one is also starting at time t equals 0. So there's no phase shift. And then the midline or the equation of axis we saw was 13.5. And so that's what goes here. Just for fun, let's also model this problem using a sine graph. So in order to do that, you first need to identify a sine graph in this graph. And so I can see a sine graph right here, right? That would be a sine graph. And this sine graph has no reflection in the x-axis. This is sine starts in the middle, goes high, goes low, comes back to the middle, right? So there's no reflection in the x-axis here. For that reason, it's going to be plus. And then it's going to have the same amplitude, It's going to have the same B value. We'll talk about the phase shift in just a moment. It's also going to have the same D value. Okay, let's talk about this phase shift now. So sine is supposed to start at time t equals 0. But this sine function that we're looking at here is actually a shifted version, right? It's been shifted 15 units to the right. And so that's why we have the t minus 15. Okay, so now let's take a look at the next part of this problem, which is saying that during the first revolution of the Ferris wheel, when is the rider exactly 17 meters above ground? And so let's take a look at our graph from the previous problem. What we're being asked is, when is the height equal to 17 meters? And so if you were to draw a horizontal line at y equals 17, right, or h equals 17, we're looking for these points of intersection. We're looking for these points of intersection. And of course, there are going to be infinitely many such points, right? But we are looking for the ones that are in the first revolution. Okay, and so that corresponds to these 2 points, T1 and T2. We can just eyeball them and it looks like this one should be around 16 seconds and this one might be around 40 seconds maybe, right? But what is the exact time value? What is the exact time value when the height is exactly 17 meters? So in order to find that, we are looking for t values in the range from 0 to 60 because we just care about the t values in the first revolution that satisfy this equation, right? Such that h of t is going to equal exactly 17 meters. And so again, we have to solve a trigonometric equation. This time we are solving this equation. And so to isolate for t, we need to subtract both sides by 13.5 and then divide by negative 7.5 to get this equation. And now what we'll do is we'll introduce a variable, let's call it beta, to represent this inside argument. So beta is equal to pi over 30t. And then we have a simpler equation to look at. Cosine of beta is equal to negative 7 over 15. Okay, so now how do we solve this trigonometric equation? For this, we have to understand when is cosine negative. So hopefully you remember that all students take calculus, right? This is the acronym that tells you in which quadrants which trigonometric ratio is positive and negative. And so we're looking for when is cosine negative. So cosine is negative in quadrants 2 and quadrants 3. And so here are my two terminal arms. My two terminal arms are right here. I'm looking for the angle beta 1 to the first terminal arm and the angle beta 2 to the second terminal arm. So in order to find these two angles, beta 1 and beta 2, let's first find the reference angle. The reference angle lies in the first quadrant, in which we take the arc cosine or the cosine inverse of just 7 over 15 without any signs. And we get a value of 1.09 radians. And so now we can find beta 1 and beta 2 no problem, because beta 1 is just pi take away the reference angle. And so that gives us a value of 2.05 radians. And beta 2 is pi plus the reference angle, And so that gives a value of 4.23 radians. Great, so now we have found beta 1 and beta 2. However, we are actually looking for t. And so now what we're going to do is undo the substitution. We are going to replace 2.05 here and we'll replace 4.23 here and solve for t, and then that will complete the problem. Let's go back to this equation. And we found the values of beta, right? But we're not after beta, we're after t. So let's undo the substitution. Let's plug in 2.05, the first beta value, and 4.23, which is the second beta value. And now you can solve for t just by dividing both sides by pi over 30. And you get these two time values, 19.6 seconds and 40.4 seconds. So these are the two times that correspond to a height of 17 meters. And actually we were pretty close. Our eyeball guess was actually pretty close. I believe we said 19 seconds and 40 seconds. If you just scroll up, you can clearly see we said about 16 seconds. But yeah, you can see that's going to be the exact answer, and 40 seconds is going to be the exact answer here. Those are the two times where the height is exactly 17 meters. Great. Okay, great. Let's take a look at one last example. And this is going to be about modeling waves. Waves are also cyclic in behavior, and so those can also be modeled by trigonometric functions. And so let's read this example. Tides cause water levels to rise to a high point of 14 meters at 2 p.m. and a low point of 2 meters at 8 p.m. A sailboat has a draft of 3 meters. What does that mean? That means that it can only move in water that is at least 3 meters deep. Okay? For time t equals 0, the time is noon or 12 p.m. On what interval is it safe for the captain of the sailboat to depart? Okay, so this is pretty interesting, right? It looks like we have these tides, right? And we have this depth of water. And we want to make sure that the depth of the water is at least 3 meters. Otherwise, our boat's going to get stuck. And so, yes, first thing we need to do is extract all the useful information and model the situation as a sine or cosine graph. And then we can probably set that equation equal to 3 and solve for the exact values. Okay, let's begin by modeling the situation. So we know that the maximum is the high point of 14 meters. The minimum is the low point of 2 meters. And so we can use the formulas to find the amplitude and the midline. So the amplitude is just the max minus the min divided by 2, which gives us 6 meters. And the midline or equation of axis is the average of the max and min, right? So max plus min divided by 2, which gives us 8 meters. Great. Now, what is the period? Well, the time between the high point and the low point is 6 hours, right? If I scroll up, you can see that the high point occurs at 2 p.m. and the low point occurs at 8 p.m. So the time between that is exactly 6 hours. But the period is supposed to be the time between consecutive peaks or consecutive troughs. And so the time between two high points is going to be actually 12 hours, not 6, 12 hours. Okay, so now using this period value, we can calculate b, because b is just 2 pi divided by the period, and that's going to give us pi over 6. Great. And now we should be able to draw a pretty nice sketch of this situation. So on the horizontal axis, I have my time. We know that at 2 p.m. we get a high point of 40 meters. Then we know at 8 p.m. we get a low point of 2 meters. And so 6 hours later, we should get again a high point of 14 meters. And so this completes a full cosine curve, right? And the curve continues here. And I guess it's going to stop here. We can't have any negative time, but this is what it's going to sort of look like. And so now to write an equation for this graph, we have to identify either a cosine or a sine curve. In this problem, we identify this cosine curve. So this cosine curve has not been reflected about the x-axis, and so we have a positive a value, and the amplitude is 6, which we found here. We found the b value to be pi over 6. Now cosine starts at t equals 0, right? However, this one has been shifted, right? This one is actually starting at t equals 2. So take into account that phase shift 2 units to the right, we have a t minus 2 here. And then the midline or equation of axis is at y equals 8, right? And that's corresponding to here. And of course, this equation will be defined for t bigger than or equal to 0, because you cannot have negative time. And so yes, this equation looks something like this, and it continues forever like that. Great. Now that we have modeled the problem and found the equation that models the problem, we can actually go ahead and answer the problem, right? We're looking for times when it's safe to depart. And it's going to be safe to depart when the water is at least 3 meters deep, okay? And so here is the height of 3 meters. Here's the height of 3 meters. And you can see right over here, the water falls between 3 meters. And so during this interval, on this interval, if the captain departs, the boat's going to get stuck because the height of the water is not 3 meters. It's less than 3 meters, right? So the boat's going to get stuck. And so if we were to eyeball the solution, it looks like the captain should set sail before maybe 7 p.m., right? And or after 9 p.m., right? On the interval from 7 p.m. to 9 p.m., that would be the worst time to go because you're going to get stuck, okay? So yeah, it looks like the correct answer should be before 7 p.m. or after 9 p.m. But let's find these exact values. How do we find this exact point where the height falls below 3 meters? And so for that, we actually have to solve this equation. We have to find t values such that the height is exactly equal to 3. That will give us these 2 points, right? Okay, so I set my equation equal to 3. I can subtract 8 on both sides, divide by 6, and I get this equation. And now let's introduce a new variable, beta. Beta is going to represent this inside argument. And that's going to simplify our equation to cosine beta equals -5/6. And now we do the same exercise. The problem has told us that cosine is negative, right? Cosine is negative. When is cosine negative? Cosine is negative in the second and third quadrants, right? All students take calculus, right? This tells you when the trigonometric ratios are positive. Cosine is positive here and here in quadrants 1 and 4. And so it's negative in quadrants 2 and 3. Great. And so I have two terminal arms. This is my first terminal arm. This is my second terminal arm. I'm looking for beta 1, which is the angle to the first terminal arm. I'm looking for beta 2, which is the angle to the second terminal arm. So the first thing you should do is find the reference angle. Find this reference angle. And so you can construct a triangle, equivalent triangle in the first quadrant, which is going to have sides positive 5 and 6, right? And so you take the cosine inverse of 5/6, and you get this reference angle of 0.59. Now we can use this reference angle to find beta 1 and beta 2. So beta 1 is pi, take away the reference angle, right? Pi, take away the reference angle, which gives us 2.56 radians. And beta 2 is going to be pi plus the reference angle, right? Pi plus the reference angle, and that gives us 3.73 radians. Now that we have found our beta values, remember that our goal was to find the time, right? And so we have to undo the substitution. We set beta equal to this. Now we have to undo that. Now that we have our beta values, we can just sub them back into this equation, right? So 2.56 equals this, or 3.73 equals this. And now you can divide both sides by pi/6 and then add 2, and you'll get your 2 times. You'll get time is 6.89 and time is equal to 9.12. And so there we go. We have found the exact values. This value happens to be 6.89 and this happens to be just after 9.12. Okay? And so yes, the captain should depart before this time or after this time in order to ensure that the boat doesn't get stuck, right? If he departs anywhere on this interval, the height will be less than 3 meters, in which case he's gonna get stuck. And that brings us to the end of this video, in which we covered some example problems relating to applications of trigonometric functions. And the main idea is really understanding this equation and its parameters a, b, c, and d. You have to be able to extract this information from the word problem in order to model the problem. And then once you have an equation, then you can use that equation to answer questions about that problem, right? You can solve that trigonometric equation to find some particular time value, or you can plug in just time values to find corresponding heights, which is easier. We didn't do that in this video, but that's pretty easy. You just plug in the time value and you find the corresponding height. We actually did the harder one, which is setting the equation equal to some height, right? And so that involves solving a trigonometric equation. And so I hope you found this video helpful.